Welcome to Advanced Energetics. So my name is François Maréchal. I'm a professor here in the PFL, working in the field of process and energy systems engineering. So what we are doing here is to try to develop methods that allows engineers doing their job in the right way. Meaning designing systems, proposing, analyzing the efficiency, and improving the efficiency of industrial processes. And I'm going to discuss here in this lecture about what we named advanced energetics. I could perhaps then say a few words about energetics, what is the meaning of energetics. So what we will do is that we are going to study the role of energy in mainly industrial processes. And energetics means how the energy is used, or what is the role that is played by energy in processes. And the definition of processes can be quite broad. I'm in the mechanical engineering department. I'm, in fact, a process engineer. Mainly, I have first learned chemical engineering before joining the department of mechanical engineering. And today I'm mainly working in Sion. So my lab is located in Sion, in a campus that is named Energypolis. And Energypolis is the joint the conjunctions of development of new methods or new catalysts or new materials for the energy transition and their implementation into processes. And this is also a reason why it's interesting for me to be to be located in Sion, because I'm working a lot with all the people that are proposing the technologies, and then I'm assembling the technologies to deliver services to the community. So just before starting the lecture, I would like to introduce first the people who are filming, because I would like to, you will see that my lectures are already available in video, but I would like to make the new versions. And so there will be someone who is going to record all the lectures, and that will be then afterwards made available. So if you miss a lecture, or if you want to recall a lecture, you will be able to go on the internet and have a look at my face, but not at another time as the one I'm speaking. And you will also have my jokes, so which might be interesting. So there will be an assistant who is going to make this recording every week. And then I would like also to introduce the three assistants who are in the background. So Francesca, you can perhaps stand up just to introduce yourself. So Francesca is a PhD student in my group, and she will be the teaching assistant leader. So she's going to help me in organizing the lecture, organizing Moodle, etc. And she will be there to answer questions. And then there will be two additional teaching assistants, so Alessio and Rafael, who will be there to help you during the course. So the three researchers there are, in fact, PhD in my group. They are working on different subjects. So Francesca is more in complex energy systems. So she's working with the energy use in an airport, a big airport. Alessio is working on industrial energy efficiency in the industry, and in particular on the operation optimization, so how to best operate industrial processes. And Rafael is just starting a PhD project on the waste management, so dealing with waste as a resource for the industry and making products out of waste. Okay, so let's start with this advanced energetics. So advanced means that we are not going to make what all the people do, but I would like to teach you new methods or another vision of how to look at energy is used in industrial processes. And first, it's perhaps interesting to see what is the importance of the energy. So you have here, you have here the word energy balance. So it's the energy that is coming from a lot of different resources. So you can see that you have nuclear up to the oil that is first extracted, then converted, then delivered to deliver the services to the world. And what we can see is that if you look at the final consumption, so the energy that is finally used, so we use the energy for 28% in transportation, 35% in services and household, and 30% in the industry. And perhaps something which is also important is that you have here 9% that is used in form of product. And that's mainly coming from the oil that we extract here, that we transform into the useful gasoline that we need for the transportation, for example. And part of it then goes, during this conversion, into the petrochemical industry to produce, on the one hand, so to produce the chemicals that are using the carbon as a basis. So all the plastics that you have here, for example, is coming from the petrochemical industry. And indeed, it is, in reality, made out of the waste of the gasoline production. Okay? Another dimension that is important here to realize is that there is worldwide 18% that is coming from, in a very special form of energy, that is electricity. Electricity is exergy, so it means that it's, you know what is exergy? Yeah? Who has already heard about exergy? Okay. Who can give me the definition of exergy? So it's always interesting. A lot of people have heard about exergy, but nobody can define exergy. So I will say it again and again and again. So exergy is the capability of producing work by doing reversible processes. So it means ideal processes. So if I'm defining the ideal processes, it means that, for example, if I have a heat exchanger, it's a heat exchanger with an infinite area. Okay, so super expensive, right? But if I'm spending this amount of investment, I will be able to do the heat exchange in a reverse way. Okay, so reversible processes are important, and they are also super slow. Okay, just because they have to be reversible. But if I would accept to have something which is super slow and that requires super big investment, then I would be able to produce from any state a given amount of work that can be easily transformed into electricity by doing heat exchange, or by doing exchanges, sorry, not only heat, by doing exchanges with only with the environment. Okay, so the two conditions is exchange with the environment and reversible processes. Okay, the advantage of having something which is reversible is that it can be inverted as well. Okay, and it means also that you do not have to care about what to do first and what to do second. They will be, you will reach at the end the same state. But something which is important is that exergy defines the capability of producing work and electricity. And electricity is a very high value of energy. So electricity is 18% of the energy consumption of the world. And as we can see here, electricity is produced a lot by fossil fuel as well. So it means that it is resulting from the conversion, mainly here from the coal and the gas. Okay, and it leads to a conversion process, like the one that you have here, which are the refineries, which is going to convert the oil that you extract from the ground and deliver in a stored and manageable way to the final user, the transportation or the households. Okay, so, and this is perhaps also something which is important, is that energy that you use is not the energy that has been harvested. And what you can see at the end is that you have an efficiency of around 60%. So it means that 40% of the energy is lost in conversion before reaching the end user. Okay, and so this is quite important. The other dimension that is important is that if I'm looking at the world, 85% of the energy that is used in the world is used in form of fossil resources. So 85%. Okay, then perhaps and even the electricity by 75% is in form of fossil resource. So coal power plants are well known to produce electricity, gas power plants as well, and it is something which is quite important. Now, if I'm looking, if I'm just looking at myself with respect to advanced energetics, what you can see is that so you have 30% here that produce the 9% of product here. That you have refineries that are needed to make the services, but also all the industrial processes that are here that convert resources into electricity are industrial processes. The same for the distribution of energy is they are all industrial processes, meaning that by looking at industrial processes, we look at the major dimension of the energy is the conversion from the resources to the final service and product. Just to give you some order of magnitude, so I'm speaking about energy, I'm going to use the petajoule, for example, as a reference. So petajoule is the joule is the way to measure the energy. Each second in the world, we consume the equivalent of 10 trucks of oil. Each second. Okay? And these 10 tankers, 3 of those tankers in oil is used for making products, and 1 out of this 10, 3 is for products, and 1 is for the industry. The rest is used in transportation mainly. Okay? The gas is mainly used for producing electricity and industrial heat. Coal is at the majority used for electricity and a little bit for industrial heat. And the overall efficiency of the electricity production is around 35%. It's just to give you some numbers that allows you to identify or to have some order of magnitudes about what we are going to discuss today. And something which is important, I'm talking about the world because I'm talking to engineers, and you will not be located in a given place or bounded by borders. It's possible that even if you are located in Switzerland, you will work on processes that are in the middle of China. Okay, so it means that there is no border, especially if we talk about technologies. Okay, so we have the big numbers here. Now, if you look at the energy used in the industry, perhaps the most important part here is that around 70% of the energy that is used in the industry is used in form of heat, and 30% in form of electricity. And of course, this varies from one sector to another one. There are sectors that consume a lot of electricity, others that do less. Something which is perhaps also very important to realize is that there is a very limited amount of renewable energy used in the industry. I would say that's mainly when you have wood boilers that are used in the industry, and that also all the products are mainly based on, are more or less only based on fossil resources. So it means that the products are not bioproducts, but are fossil-based products. Okay. Compared to the world, so Switzerland is a little bit different, mainly because Switzerland has is leaving the heavy industries outside Switzerland, so they prefer to buy steel rather than to produce steel, or to buy gasoline instead of producing gasoline. So we have only one refinery in Switzerland. The rest is directly coming by trains, trucks, and pipes. Okay, and that's the reason why the importance of the industry in the energy mix is a little bit less in Switzerland compared to other countries, which are more at the level of 30%. Okay, in Switzerland is 20. So when we are talking about industrial processes, in fact, we are talking about different types of processes. So we can have the chemical industry, the fertilizers production, fine chemicals, all the additives, so paints and pigments that are added into plastics, for example, or the pharmaceutical industry, which appears like more, you would have the idea of seeing industrial process. But the industry is also the production of cement. Okay, it's also the production of steel, of producing food is also something which needs industrial processes. Okay, you do not just take the milk and then put it into a bottle. You have to treat the milk in such a way that you can put it in a bottle in an industrial way. And then you can even imagine the production of a car as being also part of an industry. When you have to produce car, in fact, you have to melt aluminium, you have to solidify aluminium to make the engine, then you have to put the engine into the structure of the car, you have to paint the car, and all those steps requires as well energy. But then we can also consider that producing power is an industrial process. So if you look at the complexity of coal power plants, then you will see that it's indeed, especially today, like a chemical process. But even treating waste is an industrial process, okay? And it's not only just burning waste, but it's burning waste, cleaning the gas, producing heat and electricity that can be made useful for the rest of the community. And even a city is an industrial process. So if you think about a city, not only you have to heat the city, but you have to light the city, you have to treat the waste, you have to transport the water, you have to prepare the water, you have to clean the water afterwards. Okay, you have to deal with all the waste that is produced in the city, and perhaps that the best would be to use the waste heat of the industry to heat the city. Okay, and if you do this, then you do not have to buy the natural gas and to heat the city, and it would then be even more interesting. Okay, so now the industry is divided into sectors. And the sectors are more or less energy intensive. So, for example, you can see that in Switzerland, the chemistry is by far the biggest, the most intensive energy sector. Okay, consuming about 25% of the energy. But then the food and agro, because we have Nestlé in Switzerland, for example. And food typically does not like to be transported over long distances. And therefore, people prefer to produce locally, and therefore this corresponds to a certain energy consumption locally. Of course, in Switzerland, the watch industry is important, the cement afterwards, because we build a lot of buildings, paper, etc. So the steel is quite small. And something which is interesting when you look at this energy intensity, you can see that there are some processes that requires a lot of heat, which is majority heat and a small amount of electricity, and others like cement, for example, and others like the watch industry that is mainly using electricity and a very limited amount of heat that is needed. Now, what is the challenge of the industry? So you have heard about the energy transition. So we have voted the energy transition a year ago, a little bit more, which says that we are going to not renew our nuclear power plants and that we have to comply with our requirements in terms of carbon dioxide emissions, which is going to ask a strong reduction of the energy consumption. And in this, in order to reach this, at the level of the industry, it is asked from the industry to reduce by 30% the amount of heat that is consumed and by 36% the amount of electricity. And we have an horizon, 2050, for doing this, right? And it is the plan of the government, and the government will try to put measures into place in order to realize it, okay? And I would say that a priori, the challenge is on you. Okay, in 2 years you will have your diploma. You will be hired by in the industry, and you will have to at least do this, realize those targets. Where something else is the fact that your company would like also to produce more, because each company wants to grow. Okay, and this is going to create an additional difficulty, because as soon as you have to produce more, and if at the same time you have to reduce the energy consumption by 30%, but if you increase at the same time, then you will have to be even more efficient. Okay, and therefore the challenge is really there to understand how the energy is used in industrial processes, so that we will be able to reach the target. So, and the target is, I want to reduce the amount of energy that is consumed per year by still increasing my production, because I want to increase my revenue, and therefore I will have to compensate the increase of production by increasing my intensity, energy intensity. And something which is important there is that the industry has succeeded up to now to do it. So the industry, even though they are increasing the level of the production, have been able to reduce their carbon dioxide emissions, which proves that the industry can do it. Now, of course, it means that they need to have drivers for this. And one of the drivers is the CO2 problem. So the CO2 problem that is related to climate change. This is a picture of the US that is green again. So it was like it was in the past, right? I'm not sure that this is the future that we expect. So it means that we will have to do something with this. When I was saying that the CO2 emissions have reduced, so this is the proof. So this is how the CO2 emissions in the worldwide CO2 emissions have been reducing with time. Of course, you can see that there are some accidents. So 2000 here the production was lower, and then there is a boom of the shale gas that has increased the carbon dioxide emissions. So carbon dioxide are the key, and the key is expressed by this formula. We have to increase to reduce the CO2 intensity of the energy resources that we use in the processes, that we will multiply by the energy efficiency. So it's the amount of energy needed per kilogram of product, knowing that this amount here, which is the amount of product, is the amount that we would like to increase, because this will be the way for us to increase our revenues. Okay, so the three terms here, the product that will increase, and then the one that are related to energy, the energy efficiency, so energy intensity per unit of product, and the CO2 content of the energy that is used, which is going also to tell us that we have to try to switch from, or to change the fuels, switching from coal to natural gas, and then from natural gas to bio-natural gas. Okay, so that we will reduce the amount of carbon dioxide per unit of energy that is used inside the processes. When we look at what needs to be done, this is a study from the International Energy Agency. When we look at what needs to be done, it is declared that half of the effort that is needed in order to reduce the carbon dioxide emissions to a level that is supposed to be satisfactory, half of the effort is coming from the efficiency. Okay, that's why it's very important to understand the energetics of industrial processes, because we have to increase the efficiency in the energy usage. And it is expected that half of the effort is coming from this efficiency. So typically the International Energy Agency is defining the efficiency as being the hidden fuel. Okay, here half of the amount is coming from the increase of efficiency. And then the rest will come from the integration of renewable energy, which means also that we will have to think about how can we integrate renewable energy in industrial processes, right? It's not only for heating buildings, but it will be also for making new products. And then another dimension which is interesting here is the carbon capture and sequestration. So it's the integration of the capture of carbon dioxide. So it means that sometimes you will still burn fuel or fossil fuel, but you will capture it so that it will not emit carbon dioxide into the atmosphere. Okay? And then you will have to find a place to sequestrate it, which is another dimension. So we have to find where we can then store the carbon dioxide that has been sequestrated. Okay, so how do we do the how do we understand the way energy is used in industrial processes? For doing this, we have to look at what is an industrial process. And if I'm defining what is an industrial process, I would say that typically we start with raw materials that we have to transform into products. Okay? And what we have to do there is to understand the efficiency of this conversion here. So from the raw materials to products. This is typically what we name as being the, if we start from a blank page, we will name it the process design. And I was always defining, just for the anecdote, I was always defining the process by converting raw materials into products, until the time I met people from Nestlé that said, okay, but no, we are not interested in producing products, we are interested in satisfying our clients. So our product is in fact not something which is a material, but our product is satisfaction to clients. Okay, so it means that we have to be smart, because this is finally by changing this approach, they have switched from Nescafé production to Nespresso production, which is a completely new, different design. Okay, but it's important to still realize this. So the product can be immaterial. Okay, but the production process is still taking the raw materials here and transforming it into, by a list of steps which are shown here, into products. And the first step we will do is to try to do an audit on what is happening inside the process. So what it means by doing an audit is to characterize the flows. The first we will do is to write what we name the mass balance. Okay, what is the mass balance? Is just going to tell me that the raw material that is entering here, if it does not end up as a product, it will end up as a waste. Okay, and the mass that is entering my process is going to leave the process. Right? And so the first efficiency will be to try to maximize the conversion pathway from the raw materials to the products. And there has been a lot of good examples that have shown that the people were smart to transform waste into new products by a new process. Okay, so it means that we can then afterwards extend the system boundaries in order to make to limit the amount of waste that is produced. So this is the mass balance. The second dimension is the energy. So the energy can enter in form of electricity and in form of heat. So when I'm using electricity in a process, it means that I'm using a pump, a compressor, a crusher, or whatever. And if I'm using heat, it means that I'm going to cook, to evaporate, or to separate, or to dry things, or to do chemical reactions. As soon as I have the energy entering into the picture, the energy is the driver of the production process. Okay, it gives you the possibility of making the production. Okay, and for this there is another balance that is going to enter is the heat balance, or the energy balance, sorry. The energy balance is going to tell me that the whole amount of energy that is entering the system and that is not ending into a product will have to leave the system. Okay, it might happen that I have here chemical reactions. Some of the chemical reactions can be endothermic, that means that they need heat, but some of the chemical reactions can be exothermic. So for example, if you produce plastics, which is a polymer from a monomer, the synthesis reaction is exothermic, so it is delivering heat. Okay, so and this is a huge amount of heat sometimes. Okay, that can be delivered. So it's important then to understand the energy balance and to realize that at the end the rest will have to go to the environment. So let's now try to do the audit, and that's what we will do from the first step. The first step will be to say, okay, I know how much I'm consuming, and I'm going to look at how much I should consume. Okay, and for doing this, the first thing that I will try to see how my neighbors are doing the same job, so my competitors, so it's a benchmarking. I'm going also to verify that I'm not losing energy in a place where it is not needed. So for example, I'm going to isolate all the pipes that needs to be isolated. I will perhaps try to use new technologies that are more efficient than the old one that I have in my plant. And I will try to do an optimal operation. So I will try to define the optimal operating conditions of the process units in the process in such a way that I will increase or reduce the energy consumption. So I have already obtained a small reduction in the heat and electricity requirements by doing this. The next step will be to try to see if I can recover the energy. And this will be by identifying where to place heat exchangers. So placing heat exchangers means that I will have to buy heat exchangers, but I will recover the heat of the streams that needs to be cooled down to heat up the streams that needs to be heated up. Okay, so it means that I have to look at the temperatures at which I need the heat, the temperatures at which I need to cool, and then I will try to identify the heat exchangers that are the best one to be realized. So this will be a big part of the lecture I'm going to teach here. Once I have made this, then I will have an investment related to the heat exchangers, and I will reduce, therefore, the amount of heat that is needed. Okay. The next step will be to say, okay, can we revalorize the heat. So I still have waste heat that is released, and perhaps by using a tool that is developed by the mechanical engineers, which is compressors, I can perhaps take heat at low temperature and by a compressor change the pressure and then deliver the heat at a higher temperature. So it's a heat revalorization, which means that I'm going to consume a little bit more electricity to save a lot of heat. Okay, and this will be another part of our of the lecture will be to try to identify where to place heat pumps and how to at which temperature and pressure operate those heat pumps. When I have identified this, I still realize that I need heat, and heat is not necessarily something that I can buy. So typically you cannot buy heat, you can buy resources. Okay, which means that you will have to ask yourself, so is there a good way to supply this heat and electricity? And the answer is, why don't we produce at the same time heat and electricity, because we need both of them. Okay, so this is all what is related to combined heat and power production. Okay, and of course I could have also decided that the remaining part that is with the electricity could be supplied by renewable electricity. So I can also add solar panels on my roofs and perhaps have an additional amount of electricity available for supplying the electricity or the heat to the plant. And in this case, I will have a complete system that is quite well integrated, that is reusing the heat, valorizing the heat, and then supplying the heat in the smart way. But still, look, I still have heat that is leaving the system due to the energy balance. So I have to ask myself, what about reusing this heat? And the answer is, why don't we integrate processes? So instead of having only one process that is going to enter, convert raw materials into product, I can have several processes that can be integrated, that can recover the heat from one process to another one, and that will make more products, and perhaps also recycle the waste or use the waste as a raw material for doing this. And still, if I'm writing the energy balance, I will realize that I will have a remaining amount of heat, because the heat is always the expression of the inefficiency, and we cannot do perfect processes. But now we will have also to ask ourselves, so why don't we use cities to cool down the processes? And therefore, I will ask them the question, how do we connect a city and an industrial processes? And the idea is that in this case, the best way of doing it is to use district heating systems that is going to harvest the heat in one place and deliver it in another one by using pipes. Okay? And the trick is that, of course, we will have to size the pipes in such a way that we will recover the heat. That is the waste heat of the industrial processes here, which is much smaller than the initial one. So you have seen that I was starting with the size that was here. Now it is only this part, and this part is going to be delivered in the city. And of course, it's important that I size for the smallest possible sizes instead of making wrong investments by buying things that are much too big. Okay? So those are the different elements that we are going to deal with in this course. So what does it mean? I'm going back. We will study processes. We will understand why energy is useful. We will learn about writing mass and energy balances in industrial processes. We will try to identify how to recover, to avoid inefficiencies in process units, how to do heat recovery, how to do heat pumping, or to integrate heat pumping, how to integrate cogeneration, how to integrate processes together, and how to integrate processes with, at the end, with cities by enlarging the size of the system we tackled. So the goal of the lecture will be to try to give you a hint on how to do this job, which means going into an industrial process and be able to identify what is the energy needs and what should be the energy needed. What are the investments to be done? So what are the heat exchangers, compressors, turbines, boilers, cogeneration units that we have to buy? What is the system boundaries? And then afterwards, what are the investments? So because at the end you are engineers and you have to propose solutions that make sense from a financial point of view. And for making investment that makes sense, it means that each unit of money that you invest should give you a profit which is bigger than the amount that you have invested. Okay, so it means that we will have to learn how to make those evaluations and to value also perhaps the fact that in the future we will be facing the carbon dioxide tax that would then need to be accounted in the profit by reducing penalties. So for doing this, we are going to have a lecture. So it's a big lecture. Huh? So it's this lecture is 5 credits. Huh? So 5 credits means that you are supposed to work 150 hours, more or less, over 6 months. So it's not a small amount. And I must admit that I will use the time that is allocated for the credits. So it's not cheap credits that you will obtain here, because my goal is not to give you credits, but to give you some skills on how to solve the problem. Yeah, perhaps before I'm commenting this, I would like to just tell you what we will do. So there will be theory, because it is necessary to present the concept and explain how we can solve the problem. And then you will have 2 different types of actions. On the one hand, you will have exercises that we have prepared for you that allows you to apply the theory. My goal is that typically when I'm teaching, all the students say yes, yes, like this. And then as soon as you give an exercise on what I have presented, then I have not understood. Okay, I did not understand. So it means that my goal is that you do the job and then you realize where the difficulties are for you. Okay, and so there will be exercises the first 4 or 6 weeks, and then afterwards there will be a case study, which will be done as a small project, but you will have all the same problem to be solved. With perhaps different conditions of or some different technologies, but most of you will have you will deal with the same case study. And my goal will be there that you will not only learn how to analyze the energetics of a process, but also how to work in group, how to present your work, how to discuss with your boss. I will play the role of the boss, okay? So that when you ask a question, I do not have the impression that I'm losing my time, okay? Which is, in fact, one of the big problem when you will start working in the industry. So the day you start working in the industry, it's important that when you go to your boss, you present results and you know what you have done, and not asking, I do not know these aspects. Okay, so I think that's the good place to make the this exercise, and this exercise will end up with the exam, and the exam is also part of the training. So the exam will be for you the demonstration that you know what you have been doing during the project realization. Okay, just to tell you about the organization. So the lecture notes will be available on Moodle. You can download the lecture notes. the slides will be available on Moodle. The video will be available as well on Moodle. I don't want you to complain that the slides are not exactly the same as the lecture notes, or that the sequence of the lecture notes is not the way I'm teaching. So we have prepared something which is hopefully organized step by step by trying to have a good phasing between the theory and the exercise or the project realization. And of course, it does not always follow the same line as the lecture notes. Okay, so you have to know this. It's possible also that I will update my slides because when I'm preparing the lectures, when I realize that something is not clear, I'm changing. Okay, so it means that you have to just accept that the slides that you have printed just before the lecture is different from the one that I'm presenting. So I'm considering that you are at the master level, and it should not be a problem for you to be a little bit disturbed by the fact that what I'm using is not exactly what you have been printing. And also perhaps something which is important here is that my slides are a support to what I'm saying and not the lecture notes. So it means that sometimes you will see that I'm presenting the equation 1 on the bottom and the last one on the top, and of course when you read the theory, it is appearing in the reverse. So it means that you count on the slides as lecture notes. It's much more difficult to understand because you do not see the sequence, right? So you will have to accept this, okay? Which also means that if something is not clear, you have to ask me, okay? Concerning the interaction with me, so on the one hand, I will try to ask you questions, and I hope that you will not be afraid to give an answer, even though you are not sure about the answer. Okay, so it's not a real confrontation. I just want you to ask yourself questions. Okay, and then there will be another dimension that I would like to test this year, is that I will always start my the lecture, the theory, by a session about answering questions about the exercise that you have been doing or the project that you are doing. And for doing this, there will be we are going to use a tool that is named Speak Out, that you can download, that can be downloaded on computers or on your mobile, in which you will be able to ask questions in an anonymous way on each week on each exercise. And you will have 1 week to ask questions, to read the questions of the others, to vote, to say, okay, this is a question that I have as well, so I'm voting, I want the professor to answer the question, okay? And I will each week start by answering those questions. Okay, and when this session is finished, so it means that if you are at ease with the exercise and there is no question anymore, it will be very short or it will be longer. Okay, and then when I have finished this, then I will start the new lecture. Okay, and I hope that you will contribute. I must admit that I have also asked my assistant to ask questions as well, so they will feed the flow of questions because they are discussing with you, and perhaps that they will identify questions that are quite frequent that everyone will be happy to have an answer. Okay, so and I will close the list of questions. Let's say most probably on the Sunday night, so that I will have just the time to read the questions and find a way to give you the best answers. Sometimes it needs slides, or I will use my the whiteboard. I will use my iPad to give you the answers. Okay. So it means that I count on you to ask questions. Okay, and not so. And something which is important is that you will have 40 weeks plus 2 weeks of holidays to ask me questions, and I will have only 20 minutes to ask questions, which is at the level of the exam. So I think that it's quite equilibrated, okay? So the four exercises, yeah, and then something which is important is that the exercises will not be graded, okay? But we will give you feedback if you give us materials. So it means that if you send us a report, the teaching assistant will give you feedback, okay? If you do not send anything, there will be no feedback, okay? And then yes, I think that I have another, yeah. So this I will skip. So about the organization of the case study. So the case study is the realization of a real project with data coming from, supposed to come from in the industrial application. You will have to work in groups. So I hope to build groups of maximum six person that will be afterwards divided into subgroups of 3 that will deal with different values for the sum of the parameters. You will have the teaching assistant who will be there. You raise your hands and they come and they give you an answer. There will be not a teaching assistant associated to one of your projects, because as they have to travel sometimes, it's easier to have all those assistants available everywhere. And if you need to meet them, you can even take fix a meeting with them. They are all located in Sion. It means that if you need to meet them during the week, you have to set up a video conference with them. Okay, but I'm sure that they will be available. The final report has to be delivered after the winter or the Christmas holiday. So the exact date is in fact typically 1 week before the exam, but I do not know when is the exam date today, so I cannot give you other hints than this one. Something that is important is that you are going to write a report that is a group report, and you all sign the report. So you are responsible for all what is written in the report. Okay? Something which is also important is that there will be not a real amount of grades given by the report, because the test, the case study is there to help you preparing your own exam. And at the exam, you will have to prepare one poster in which you will present how you have solved the problem. Okay? And when you will come at the exam, yeah, it is explained here. So when you will come at the exam, you will have 20 minutes, and the 3 first minutes will be there to just explain what is written on the poster. Okay, so from my side, it's the best way I know to be really concentrated when you start an exam is to make the summary of the course. Okay, so that's my goal with this poster. Typically, the students like or appreciate the evaluation, so they say that it's a good way to assess what I have learned. Okay, and I think that typically I'm well in phase between how the students perceive the grade that they have and the grade that they have obtained. Okay, so but something which is important is that it's your presentation, it's not the presentation of the group. You do it on an individual basis because it serves as a support for the exam. Okay, and my goal is that I have to be sure that you understand the theory. So it means that if you have to solve the problem in another industry, you will know how to do it. Okay, and I don't want you just to explain what you have done, but if you have worked in the dairy in a dairy process, and now I'm asking you to work in the cement industry. I want to be sure that you will know how to do it. Okay, and then to help you preparing the exam, there is one document that is very important that I do not understand why the students are not using it. Okay. But I'm saying this each year, and I'm always surprised. So I'm giving you the list of questions that I'm asking at the exam. Okay? So, and there are still students that are surprised. Okay? So you have the list of questions. It is available on Moodle. You do not even have to make a picture. So it is available on Moodle. You can download it. And I show you also that what I have done is that I have even added here some bullets that you can fill to decide what is how much you understand this topic. Okay, so and if you do it all over the year, normally at the end you should come with everything which is fully black, and the part which is not fully black needs to be worked a little bit more. Okay, and officially I don't see a possibility for you to be surprised by the questions I'm asking. Of course, I will not start with the first one. But the exam is not one of the questions, is all the questions. Okay? So, having said this, I just would like also to give you some, and then I will stop because I have taken a little bit more time. But we have 5 hours, so it's we make a longer break if you want. Just a last dimension is the feedback of the students from the evaluation and some of my comments. So slides are not clean and clear, and my interpretation, I'm open to critique, but my interpretation is that mainly because you are used to have slides with bullets, points. Okay, so a lot of text because it's easy to consider this as lecture notes. My slides are not lecture notes. You have lecture notes and you will practice, which is the best way to integrate a theory. Okay? Lecture notes are not well organized, and this is sometimes difficult to interpret. It's mainly because it does not follow the same sequence as the sequence that I'm following during the course. But this is also done by purpose because I don't want you to have to learn something in a linear way. You have to be able to activate concepts. Okay, and this is the reason why they for example, you will see that there is a part with theory and then there is a part with an application. While in the lectures, we will merge theory and application. Okay, so the exam method is not ideal, and this was something which was difficult to understand because I'm giving this exam since 10 years, and I don't see a better way of doing it. And in the past, I was doing a different way, and I didn't have the impression of being correct with or fair with the evaluation. So I think that, and at least Francesca and Alessio did also participate to the course and have had the exam. They can give you the experience. I think it's a good way. Yeah, something which is also important. There are some people here who have not perhaps the background, necessary background, that perhaps did not have a very detailed training on exergy or thermodynamics. The 2 first week is an exercise that is mainly looking at writing mass and energy balances and reading a flow sheet. Okay, so for those who have not the background, those 2 weeks are the most important. Okay, and do not hesitate to ask me or the assistant if you have the impression that something is not clear. Okay, we will not kill you. We will not penalize you if you are asking questions. Okay, so we know that some of you are in the minor and coming from another background and mechanical or chemical engineering. There are things that have not been taught in the past. Okay, so use those weeks. So the two, this week and the week after, just to learn the basics, and do not hesitate to ask questions. Okay. So we have integrated the project in a more detailed way by the case study. So normally this is solved, and the office hour, I have already told you that the TA will be available for answering questions out of the 5 hours of interactions that we will have every morning, every Monday. Okay. So do not hesitate to ask questions, and I'm sure that they will answer. So those are the students, and yes, by this I think that I'm going to stop, and I'm going to make a break of 15 minutes, and after the break we are going to discuss about how we start analyzing the energy consumption of a process. Do you have questions? No questions? Yeah.
Maybe just about the organization. So we're in a group of 6 and then we're split into subgroups.
Yeah.
We're going to work on different subjects then?
No. So all of you will work on the same type of process. Okay? And then so it will be a dairy process, okay? And you know that with a dairy you can produce mascarpone, dry milk, etc. And you will have a repartition of flow which will be different between the different groups, okay? And in addition, we can have a dairy process in Switzerland, one in Germany, one in France. And it happens that the price of energy in France, Germany, and Switzerland are different, which means that at the end, the optimal solution in Germany is perhaps not the one in France. Okay, and so at a certain time we say, okay, you are the process, you are the group that is dealing with the integration of mascarpone production in France. Okay, and then you study the mascarpone, and then at the end, so due to the fact that the electricity price is different, you will end up with another suggestion at the end. Okay. But the more you discuss between you, the more efficient you will be in solving the problem. Other questions?
The poster will be the same for the group, or
no.
Everyone has to?
No. The poster is an individual poster, and the reason for this is that so it's the exam. Okay, so you start the exam by explaining a poster, which is that I hope you have prepared let's say the day before. No, because it's important to know exactly what is there, because the first thing you will do is that you will give me the story which is on the poster. Okay, and it's, at least from my experience, it's a very good way of being concentrated, okay, focused on the exam. So you know what you are going to tell me first, and this will be the summary of the course. We have done this, we have done this, we have done this for this, we have done this, we have done this. And of course I will say, explain me this, right? Yeah?
So it's not actually related to the project, it's just a course summary.
No, it's related to the project because the case study serves as a basis.
Okay.
So instead of saying, okay, I have solved the heat exchanger network design, okay, you will tell me, in the dairy process, I have identified that I can recover heat from this flow to heat up this one. Okay? And I have done it in this way by making those assumptions. Okay? So it's really a support. Yeah?
Will you determine who's in which group, or is it our choice?
What is the strategy? The groups, they can group themselves, or do we impose the, huh? So, you are free, but not more than 6.
Yeah.
6 is already a lot, that's why I'm dividing into 3. Okay, and don't forget that the goal is not to realize a project, but to learn the skills by doing the case study. Which means that it's not important, it's more important to participate than to have a very good project. Okay. Other questions? If not, then I'm doing a break of 15 minutes, huh?